Okay, good morning, students. Yesterday, we just started the chapter number 12, electricity, and I hope you all understand that topic what we learned yesterday. And I want to summarize what we learned. Yesterday, we talked about the complete overview of chapter 12. So, there we learned just a short clips of this chapter 12, and then we learn the introduction part, what is electricity, and what we are going to learn from this chapter. Then we move on to electric current, and we learn the definition of what is electric current, right? I hope you will know that formula I is equal to Q by T. It's very important. You have to keep it in your mind. And also we learn what is electric circuit and how the current flows in the electric circuit, and also how the electrons moves in the electric circuit, right? That also you should know. And then we learn the SI unit of current and electric current, electric charge, and also we learned on potential, right? Electric potential, and also electric potential difference, right? So these are the things we learned yesterday, right? So today we are going to learn on a new topic, and that is Ohm's law. Yeah, so today the topic we are going to learn is Ohm's law. So all of you turn to page number 203 in your book. 203, Ohm's law. And in page number 203 you can see the symbols and the components. There is a circuit diagram, and these are the symbols and the components, and you have to know each and every symbols. For example, electric cell, what is electric cell and how it is denoted. Always the longer line is positive and the shorter line is the negative symbol. And battery is the combination of two or more cells, right? And you can see here plug, key or switch. When it is in open, you see that there is no point in that. Okay, that means it's an open circuit. In a closed circuit, you can see there is a point will be there at the middle. That means the circuit is closed. Only when there is a circuit closed, you can see a current flows on the circuit. And this is a wire, and this is a crossing wire. An electric bulb is denoted like this in both the way. And these are the resistors. We are going to deal and we are going to talk about resistors today. So this is the symbol of a resistor, of the resistance. And this is the symbol of an ammeter and the voltmeter. At this chapter topic, Ohm's law. What is Ohm's law? That's an activity which is given in your book, and we are going to talk about this activity only. Activity 12.1. So take your book and read the activity carefully. Okay, I'm going to read it. Set up a circuit as shown in the figure, consisting a nichrome wire X and Y length, say 0.5 meter, an ammeter, a voltmeter, and 4 cells, that is 1.5 volt each. So this nichrome wire is nothing but it's an alloy. Okay, nichrome is nothing but nichrome is an alloy. It's not a metal actually. Okay, it is a combination of nickel, chromium, manganese, and iron metals. So nichrome is an alloy, right? Ohm's law. If you want to learn Ohm's law, we have to learn this activity carefully. So listen to this activity. So this is a circuit diagram. So what are all the things which is present in the circuit diagram? We have a battery here, we have a cell here, right? And this cell, first we have connecting only one cell. Okay, and this is the wire. These are the wires, right? From X to Y are wire, and here we are connected with a resistance, and to identify the potential difference between these two wires, so voltmeter is connected in between them, right? And this is an ammeter. It is connected here to identify the flow of electric current. and switch is here, and switch is already in the on position. Clear? So what I am going to do is, first using only one cell, I switched on the electric current. What happened when we switch on the electric current? Current flows inside, and you can see, and we have just taken 1.5 volt at first. We are not taking completely, only one cell, so it shows first 1.5 voltage. Okay, think that in a voltmeter. Okay, in a voltmeter, for example, this is a voltmeter, think in that way, and it shows only 1.5 volt first. Okay, and in ammeter it shows 0.075, think in that way. That means we know that when 1.5 volt of current is passing through, and it shows 0.075 current, which is shown on the ammeter. That means 20 difference. And if I increase more, if I add another cell in here, if I'm again adding another cell, that means again addition of 1.5 volt, so totally 3 volt of potential difference, which is shown here. And then current will also increase more. Once the potential difference is increased, current will also increase. How much? Again 20. The third time, again I am adding another cell. So as much as cells which is added continuously, I find there is increase of 1.5 volt of voltage. I'm just increasing it continuously. Current that I am seeing in on an ammeter is also increased. So if I make a graph, it shows like that. You can see here, as much as current is increasing, goes on increasing, the potential difference will also keep on increasing. So as a voltage increases, current will also increases. You can see as a voltage increases 1.5, it increases, then the current will also increase to 0.075 at the first time. When I again add another battery, another cell, and 1.5 volt, that means totally 3, again it increases to 0.15. That means it is increasing more. How much of voltage I am increasing, that much of current is also increased. I hope you all understand it. So V is directly proportional to I. What is directly proportional? If I keep on increasing the voltage, current will also increase. If I decrease the voltage, the current will decrease. You all understand? So V is directly proportional to I. To make this proportionality sign, if I want to take out this proportionality sign, I have to, if I want to make equal to sign, then I have to introduce one constant here. And what is that constant? And that constant is R. And what is R here? R is nothing but the resistance. Clear? Resistance. What is resistant actually? Resistant is nothing but the thing which resists the current that flows on the wire. Okay, you can look at it. This is what the this is how the current flows in the wire, right? And what the resistant will do, this try to resist, that means stop, or not stopping completely. Resist means it minimize the flow of electron, or stopping the flow of electrons. You cannot say the word stopping, it try to minimize, resist. That is what the meaning of the word resist. Okay, that is what resistance. So if I want to write this equation, I can write like this: V is equal to IR. So we know that voltage or potential difference is directly proportional to I, electric current, right? So if I want to remove this proportionality sign, I use this constant R. So now the formula comes at V is equal to IR. Now I'm in page number 204. You can look at there the last three lines. I'm going to read it. It's very important. You can underline that also. R is a constant for the given metallic wire at a given temperature is called its resistance. So you know what is R now. R is resistance. It is a property of the conductor to resist the flow of charge through it. Through it means through the wire, right? So this resistance is going to be going to written as a symbol called ohm. Okay, ohm, and ohm is a Greek letter. Ohm is a Greek letter, and it is written like this, ohm, right? Ohm. So how can I write like this? Even if I want to find the resistance, what is resistance now? Resistance R, keeping the R here at one side and taking the I on the other side, it will write like this: R is equal to V by I. So 1 ohm is equal to V is potential difference, we know that, and what is the unit of it? It is volt. And what is I? I is written as an ampere, right? I is nothing but the electric current, and electric current will be written as ampere. So in other word, that means even if I want to find the I can use the same formula. So you can see this. I can this is one formula 1, and this is for R, and even for I we can make I, and taking that side V by R. That means current through the resistor is inversely proportional to its resistance. Current through the resistor is always inversely proportional to its resistance. Okay, based on that we'll do one example, so it will be easy for you to understand more on it. There's a question here. You can pass on to this. That means you can read this question carefully and try to give an answer by yourself. How much current will an electric bulb draw from a 220 volt source if the resistance of the bulb filament is 1200 ohms? Okay, so how much current? That means you have to find I. You know what is current? Current is I. An electric bulb drawn from 220 volt V is given, and we know what is volt. V is about the potential difference, right? If the resistance of the bulb of the filament is 1200 ohms, and this is what the resistance given. So you have to find R, I. So R is given, V is also given, and we have to find I. So using this formula, I is equal to V by R. I is equal to V by R. 220 divided by 1200 is equal to 11 by 60. So we get I is equal to 0.18 ampere. So I is always written as ampere. I told you unit is very important, right? So in two more examples also I'll give you as a homework, and I put it on the description. You take that as a homework and please do that in your home, okay, and send it through WhatsApp. We are going to do one more example here. So I'm going to read this question again. Potential difference between the terminals of the electric heater is 60 volt. Okay, terminals at the end, right? Potential difference. So when it draws a current of 4 ampere from the source, what current will the heater draw if the potential difference is increased to 120 volt? So you have to listen this question properly. So first thing is a potential difference between the terminal of the electric heater. That means the potential difference, the voltage which goes inside the electric heater is 60 volt, right? And it draws a current of 4 amp. So how much current which is dropped? That means it takes 4 ampere from the source. Okay, what current will the heater draw if the potential difference is increased to 120 volt. So you can do one thing. While reading this question, you can even pause the video and you can write that question, and then try to solve by yourself. If you can't solve this, this is actually comes as a 1-mark question. Sometime this can be asked as 1-mark question, and also sometimes it can be asked as 2-mark question. If it is asked in 1-mark question, you can do it directly. I will teach you how to do it directly. And also, so if it is asked in 2-mark question, you have to derive how this example, how to derive this and also write this numerical problem. Okay, let's do it. Okay, in Ohm's law we learned one thing, that means as much as voltage increased, that much of current will also increase, right? That means V is directly proportional to I. So you think that if voltage is doubled, definitely I, that means current, will also be doubled, right? You think that in this question, if V is equal to 60 volt is given actually, and also there is another volt is also there, V is equal to 120 volt, 2 volts are given, right? So if you see that it doubled, first voltage 60 and another you can see it's doubled, right? The potential difference is always double. If V is doubled, then I is also always going to be doubled, right? If here you can look at it, even it is actually as a clue for us. So if it is asked in 1-mark question, then we can do it very easily. Simply we can write it as current. How much current is actually given? I is equal to 4 amp, and definitely if I increase this, so voltage is directly proportional to I, that means if it is 60 and the current will be 4, then if it is doubled, you can look at it 120, then current will also be doubled. So how much it comes? 4 head. If it is 4, then it comes as 8 amp. So answer is going to be 8 amp. So if it is asked in a 1-mark question, that's it. You can do it like that. I hope you all understand that. V is directly proportional to I. That means if V is doubled, then I is also going to be doubled. And V is 60 and another V is also given, it is 120. It is doubled actually. So definitely current will also be going to be doubled. So if current is 4A, then according to the formula, then current is going to be doubled as 8 amp, right? So suppose if it is asked in a 2-mark question, how to solve this? Take an example. We make it as a 2 cases, case 1 and case 2. In case 1, it shows V1. So case 1 है तो V1. V1 is potential difference, that V voltage is 60 volt. Okay, I can take it like that. And current V1 means I1 is equal to 4A. Okay, in case 2, it comes V2 120 volt, and I2, we don't know that how much current, right? So if we don't know, then try to use the ratio. We try to take a ratio. If I take ratio of these two, V1 by V2, so how can I write here? We know the formula of Ohm's law, right? V is equal to IR. In both the cases, resistance are going to be same. So V is equal to IR. So I V1 means I1R divided by V2 means I2R. So both R will be getting cancelled. Then what happens? So I need I2, right? This is what we need to find. So take I2 in one side and take the remaining on the other side. So what it comes? It comes as I1 into, so I am writing it here, I2 is equal to I1 into V2 divided by V1. So what is I1? It's 4 amp, right? And then 4 amp into, and V2 is here, it is 120 volt divided by, and then V1 is 60 volt, 60 volt. So we know that it is 6 2s are 12. So it comes as 8, 4 into 2, so it comes 8 amp. So I2 is 8 amp. So finally we got the same. If it is asked in a 2 mark, so you have to derive the formulas with the help of a formula. If it is asked in a 1 mark, you can use just a mind or a brain to think and you can give an answer properly. Clear? Okay, now we are going to learn on resistance. As we learn resistance, and where we started resistance in an Ohm's law, right? Ohm's law, what we learned? Ohm's law. Can anyone tell me what is Ohm's law? Here, V is equal to IR, right? So this R only we are going to learn now, and R is a proportionality constant and it represents resistance. Okay, resistance, in the name itself we know that resist, it resists the flow of current. Okay, so if you take an example, all the metals are good conductors. Good conductor means they allow electricity to flow in a metallic wire. Why it allows the electric current to flow? Because they resist very less. That is why it allows the electricity to flow. If the resistance is less, then the current flows will be high. You take an example, and this is a metal, or this is some kind of a metal. Look at it. Okay, and here you can see, if the electrons here, these are the atoms which is present on a metal, and these are the atoms which is present on the metal. You know how the current flows? Only on the top shell we have the last electron. We know that in chemistry also we learned the valence electron, which is on the last shell, right? So what they do, these electron, they try to jump into the other atom of the last shell, and then again jump into the other atom of the last shell, then they keep on going. Okay, this is how the flow of electron goes in an electric conductor. So what happen if many electrons are there or many atoms are there, so definitely you can see it resists a lot. Okay, there will be an high resistance will be there. You can see that if there is more number of an atom, definitely have an high resistance. If they have a very less number of an atom, the current flows very smoothly, just jumped, and there is no one is stopping them. You see that, but here many atoms are here, many electrons are there, many atoms are there to stop the flow of electrons. They won't move freely, so lots of resistance will be there because lots of electrons or lots of atoms are here. But here you see very few number of an atoms, so very less resistance, they smoothly flow. Okay, you can see non-metals have high resistance. Why they resist a lot? Because that's why the current is not passing through. Okay, in non-metal, if you see an example of a wood or a plastic, they never allow the electricity to pass. Why? Because there is high amount of resistance will be there, so they never allow the electricity to pass. But in metals, you can see a less resistance, and it allows the electricity to pass very smoothly. Okay, when we learn on resistance, we should learn what are the important factors that affect resistance. Now we are in page 206. So turn to your book and take 12.5 factors on which the resistance of a conductor depends. Okay, what are the factors? First factor is the length, L. If there is a long wire or the length of the conductor is too much long, length is very high, then the resistance will increase by increase its length. Okay, if it is a short wire, the resistance will be very less. If it is a long wire, definitely the resistance will be more. So that I can write it as resistance is directly proportional to length. That means when we increase the length of the wire or length of the conductor, resistance will also increase. If we shorten the length of the conductor, and the resistance will also less or a decrease. The second one is area of cross section of the conductor. If I take a very thin wire, right, and the current is passing through in this very smoothly. Okay, if I compare with a very thick wire, okay, area of cross section of this resistance is too much high. First I take a very thin wire and the second one is the very thick wire, right? So area of cross section is a little increased. So when area of cross section of the conductor increases, the resistance will decrease by increasing its area of cross section. So how can I say that? For example, and this is a wire which is having lots of electrons in that. Okay, think in that way. If large number of electron, the long length will be there. Okay, so what happens? Resistance definitely increases, right? And if I increase the cross section, this is a thin wire. If I increase the cross section with the same amount of electron is also present in this, you can look at it. So the flow of current will be smooth because it become thicker than this. So resistance will decrease by increasing its area of cross section. So we can write it as resistance is inversely proportional to area of cross section. Okay, directly proportional means resistance increase with the help of no, this is directly proportional. Length increases, resistance will also increase, but here it's not like that. Resistance, if it is increased, when it will increase? When this area of cross section will be decreased. When the area of cross section increases, that means if become more and more thicker, then the resistance will become decreases. Clear? Okay. And the third main important factors that affect this resistance is nature of a material of the conductor. Some material, they resist. Okay, their nature itself, they resist the flow of electricity. Some, they even allow the electricity to flow. So nature of the material is also very important. The fourth one is the temperature. As we know that when we increase the temperature of the any metal or anything, normally what happens? If I increase the temperature, the particle which is present inside the metal, they started to move faster randomly, right? They move like that randomly. So what happened? When they move randomly, lots of collision will be takes place between them. So when they move like this, they collide with another one. Collision will also increase, and that increases the resistance. Will you understand? So temperature is also very important factors that affect the resistance. So if I combine all these things in a single formula, so resistance is directly proportional to length and resistance is inversely proportional to area. So I am combining these two formulas as one formula. So resistance is directly proportional to length and inversely proportional to area of cross section. So this is a proportionality sign. So I told you, if I want to take this proportionality sign and I want to make it equal to sign, I have to put one constant, and here, and this is the constant called rho. So it will be written like this, okay, rho. And rho is nothing but it is talks about the specific resistance, or in other word, it is talks about resistivity. Okay, so always this rho depends on the material of the conductor. I give one example for that. And take your book, turn to page 207. You can look at it. Different kind of materials are there, and you see their resistivity different. They all have a different types of resistivity. Each metal have a different types of each alloys have a different types of resistivity. That is what I am going to I want to specify here. Rho depends on the material of the conductor, right? So I want you to underline few things which is present on this book. So take down these. So rho is the constant proportionality, and it is called electrical resistivity of the material of the conductor. Please underline that in your book. Also, the SI unit of resistivity is ohm meter. Okay. Simply, if it is ohm means what? It resistance. Okay, and resistivity, it talks about ohm meter. Clear? So what we learned now is actually given in your book only. You can turn to page number 207, and at the top paragraph you can see everything. So you can see we observe that the resistance of the conductor depends on its length, first one, on its area of cross section, the second one, nature of the material, right, third one, and also temperature. Temperature is also very important thing, and that also you keep it in your thing. But resistance material vary with temperature. Here it is given in the second paragraph, so you can add temperature also along with that. Okay, I want to summarize what we learned today. Today we learn on Ohm's law, and for that we learn an activity, and then through that activity we learned whenever there is an increase in voltage, the current will also increase. That means the V is directly proportional to I. So to remove this proportionality sign and make it equal to sign, we put R here, and R is the proportionality constant, and here R represents resistance, and which is ohm, which can be written as ohm. Okay, and so in this, using this formula, we can make even 1, 2 and 3 formulas are made with this. See, this Ohm's law is very, very, very important for your exam, and definitely one question is going to come from this Ohm's law, either through activity or with this formula or some numerical formulas. Okay, but Ohm's law is very, very important. And then resistance. Okay, today we learned two very important thing: Ohm's law and resistance, and how this factor, what are the factors that affects resistance. So this is our mind map. So we learned electric circuit, electric charge, electric current, potential difference, Ohm's law, resistance. Up to here we learned, right? So we have a few things left, and this is also we learned. R is equal to rho L by A. So this is also we learned. So in the next class we are going to learn on resistance of in series and resistance in parallel, electric power, and Joule's law of heating. Okay, so only 2-3 topics left, and thank you, students. So I have given 2 questions in the description page. So please take down that question and try to solve by yourself, and if you can solve the question clearly, well and good. If you have any doubt, please ask me, then I will solve and send it through WhatsApp. Thank you, student, and have a nice day.